I'm Anil Kumar. In this video, I will introduce you to a very important concept of generating fractals. So we are doing complex numbers and we will see how fractals can be created. Functions that generate some fractals are in the form f equals to z squared plus c, where c is a complex number. Fractals are created by iteration, which means that the function f is evaluated for some input value of x, and then the result is used as the next input value, and so on. So that's the process of iteration to create fractals. Now here we have a question. The question is, find the first three output values for f equals to z squared plus I. So this is iota, right? Imaginary number. As you know, I square is minus 1. It is that I. So f equals to z squared plus I with the first input value as z equals to 0. You can always pause the video, answer the question, and then look into my suggestions. So as described here, we will have initial input. Let me say initial input on the function, and that will result into first output. Is it okay? That will result into first output. And this first output will actually become your second input. And that will result into second output, correct? So that is how the process will be continued. In this example, we'll just find three outputs. The function given to us is f equals to z squared plus iota I. So if I introduce the initial input, which is equal to 0, right? That is given here with first input as z equals to 0. So we'll introduce 0 for z and then find the output. So that gives us the value as, if I write 0 here, I get 0 square plus I. And therefore, the first output for me is I. Now, I, which is the first output, becomes the second input. So second input for us is z equals to I. So that is what has been described here. So the output becomes the input. Perfect. We'll again evaluate the function for z equals to I. So we have I squared plus I. So I squared plus I. I squared, as you know, is minus 1. So we get minus 1 plus I. So the second output is minus 1 plus I. Now that becomes our third input, right? This becomes our third input. So I hope the process is clear, right? So we'll do one more example based on this. So z is now equals to minus 1 plus I. We'll evaluate the function once again to get the third output. So z is minus 1 plus I whole square, and here we have plus I. So let's expand this. So a square plus b square plus 2ab minus 1 square plus 2 times minus 1 times I plus I square. So that is the expansion of this part, plus I we again have here. So let's calculate what this is. Now minus 1 square is positive 1. Then we get minus 2I, and this is minus 1. I square is minus 1 plus I. 1 minus 1 is 0. Minus 2I plus I is minus I, right? So we get minus I as our third output. So this becomes our third output. So I hope you have understood the process of how to use the output as the input. So that's kind of a feedback, and this loop can go on, right? So we'll restrict ourselves to just three outputs. So our three outputs are I, and then we had minus 1 plus I, and the last one is minus I. So from here, let's move on to the next example, and then we'll have a practice question for you. I hope you have understood the concept. Feel free to write your comments, share my videos, and if you like, that'd be great. Thank you, and all the best. So now here is a second example on fractals. Let's remind what fractals are. Fractals are created by iteration, which means that the function f is evaluated for some input value of x, and then the result is used as next input value, and so on. For the first three output values of, find the first three output values. So the question here is, find the first three output values of f of z equals to z square minus 1 plus I, with first input as z equals to 0. So we'll find f of z, f as a function of z, a complex number, equals to z square minus 1 plus I, correct? Now we are given here that the input is, let me write down input, is z equals to 0, right? So that is our first input, input number 1, okay? So we can calculate this, f of 0, that is the first input, equals to 0 square minus 1 plus I, and that is minus 1 plus I. So this becomes our output number 1, correct? So we'll write this as output number 1. Now this output becomes the second input, right? So this output becomes the second input. So we can write down here input number 2 is the same as that. So that becomes the input now. So we can now again calculate the value of the function where z is minus 1 plus I, correct? So we'll replace this z with minus 1 plus I. So we get minus 1 plus I whole square, and then we have minus 1 plus I, correct? So you could actually expand this and then do the needful, or what you can also do is you can take minus, okay, let's expand and do. So minus 1 square is, let's rewrite, minus 1 square plus 2 times minus 1 times I plus I square, right? And we have minus 1 plus I. So that gives us minus 1 square is 1. Then we have minus 2I. Then we have I square, which is minus 1. And then minus 1 plus I. Combining the numbers, we get 1 minus 1 minus 1 gives me minus 1. And minus 2I plus I gives us minus I. So that is our output number 2. This output becomes our third input, right? So we have input number 3 as minus 1 minus I. So let's substitute that. So f of minus 1 minus I is equal to what? Z square is replaced by minus 1 minus I whole square minus 1 plus I. Let us expand this. So a square, which is minus 1 square, minus 2ab minus 2 times minus 1 times I times I square, which is plus I square, and we have minus 1 plus I. So let's combine the like terms. We have plus 1 minus becomes plus 2I minus I square is minus 1 minus 1 plus I. So that gives us these minus 1 remains, 2I plus I is plus 3I. So that becomes our output number 3. Do you see that? That is output number 3. So we get 3 outputs which are required. So the answer is outputs are, this process can go on, correct? The outputs are minus 1 plus I, and then we have the second output as minus 1 minus I and the third output is minus 1 plus 3i. Correct? So that is how you can create by iteration functions values. Now here's a practice question for you. Just a reminder, functions that generate some fractals are in the form of f of z squared plus c, as we saw in the first example, where c is a complex number. Fractals are created by iteration, which means that the function f is evaluated for some input values of x, and then the result is used as the input value, and so on. Find the first three outputs for f of z squared plus 2i. So it's very similar to what we took. We earlier took z squared plus I. This time the function is equal to z squared plus 2i. So in this particular case, we can write inputs here. So this is for you to practice. Outputs. First input is given to you is z equals to 0. So what you get is the value of the function f of 0. That f of 0 becomes your second input, right? And then whatever you get here will come as the third input. Do you see that? To get you the final answer, correct? Or the third output. So process will be repeated, and then you'll get a set of numbers. I hope it's absolutely clear. Feel free to share your comments and views. Thank you, and all the best.